Question 8, exercise 10.2. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. So, solving question number 8. So, solution 8. Here, quadrilateral ABCD is drawn to circumscribe a circle. To circumscribe a circle. Therefore, what we can see that this AD, AB, BC and DC, they all will become tangents, and therefore we can say that, therefore, let us write this here, therefore AB, BC, CD and DA are tangents to the circle, tangents to the circle at point, you can see from the figure what are the points at point P, Q, R, S respectively. Therefore, what we can say that we know that whenever there is a point outside the circle, the tangents drawn from that are equal. So therefore we can say that AP will be equal to AS. So let this be 1. Similarly, we can have BP equal to BQ. So let this be 2. Then similarly we can have CR equal to CQ. So let this be 3. And similarly we can have dr equal to ds, and let this be 4. Why? Because tangents drawn to a circle from external point are equal. Tangents drawn to a circle from an external point, are equal. Now let us add them. So adding 1, 2, 3 and 4. Adding 1, 2, 3 and 4. So why we are adding them? Because when we add them, we will see that AP plus BP will give us AB. So that is what we are having in the left hand side, and also adding CR and DR, we will be getting equal to DC, and we will check whether on adding them are we getting AD plus BC or not. So let us do that thing. So adding 1, 2, 3 and 4, we will be getting AP plus BP, that will group together, seeing the figure, plus CR plus DR, so that also will group together, CR plus it is DR, CR plus DR, and that is equal to, now when we add on the right hand side, there also will group accordingly here, seeing the figure. So if you see that AS and DS together will give us AD, so we will group AS and DS together, AS plus DS, and plus we can group BQ and CQ together, so BQ plus CQ. So now let us go further. So from the figure we can see that, as already discussed, AP plus BP is giving us AB. So we will write here AB plus CR plus DR, that will give us CD, equal to AS plus DS. So in both the lines, what is common? S. So combining them, will be getting AD. From figure also we can see that AS plus DS is equal to AD. So we will write equal to AD plus BQ plus CQ. So what is common in this? Q. So adding them, we must get BC. So let us see the figure BQ plus CQ, that is BC. So this is what we need to prove. So what we have to prove, you see here, we have to prove that AB plus CD is equal to AD plus BC. So AB plus CD is equal to AD plus BC. That means whenever a quadrilateral ABCD is drawn to circumscribe a circle, in that case the sum of the opposite sides of the quadrilateral. So what is the opposite sides of AD? That is BC. So AD plus BC will be equal to the sum of the other opposite sides. That is AB plus, here AB plus DC is same as AD plus BC. So this is what we are getting. So with this, question number 8 is complete. Question number 9, exercise 10.2. In the figure, xy and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C, intersecting line xy at A and line x dash y dash at point B. Prove that angle AOB is equal to 90 degrees. So we have to prove that this angle AOB is 90 degree. So for this we will do construction. And what is the construction? We will join O and C. So construction join O and C, join O and C. So why we are doing this construction? Let us see it here. First we will do the construction and then I will explain you the reason behind that. So this is our O and this is C. So now this construction is complete. What is the reason for the construction? Here still is so now it is complete. So what is the required for this construction? Because when we do the construction, then triangle POA and triangle COA both will become right triangle here, because OP and OC are radius and these two are tangents, so they will become a right triangle. And then AP and AC will be equal, also OP equal to OC and angle P equal to angle C, so they will be congruent. And therefore, suppose we take this as angle 1 and this is angle 2, so both will be equal. Similarly, we can prove that these two are also equal, that is angle 3 is equal to angle 4. And what we will get? Angle 1 plus angle 2 plus angle 3 plus angle 4, that will be 180 degree, because PQ is a straight line. And we can replace angle 1 with angle 2 and angle 4 we can replace with angle 3 we can replace with angle 4. So we will be getting here, in place of angle 1 plus angle 2 plus angle 4 plus angle 3, we will get 2 angle 2 plus 2 angle 4 equal to 180 degree, and that will give us angle 2 plus angle 4 is 90 degree, and that is what we require, that is angle AOB is 90 degree. So now let's start the proof. So in triangle, in right triangle POA and right triangle COA, we have angle P equal to angle C equal to 90 degree. Why it is 90 degree? Because tangents and radius are perpendicular to each other at the point of contact. Tangents and radius are perpendicular to each other at the point of contact. So here what we can see, that this xy is a tangent and point P is the point of contact. Therefore, OP will be perpendicular to the tangent xy. Similarly, AB is tangent to the circle at point C. Therefore, OC will be perpendicular to AB. So that is why we are getting angle P and angle C both as 90 degree. Now next, also we have PA equal to CA. Why is PA equal to CA? Because tangents drawn from external point are always equal. So PA equal to CA, because tangents drawn to a circle from external point are equal. Tangents drawn to a circle from an external point are equal. From an external point are equal. So this is what we have got. And also we can see that in both the triangle, that is POA and COA, OA is common. OA equal to OA, common side. Therefore Therefore, what we can say that triangle POA and triangle COA both are congruent. Triangle POA is congruent to triangle COA, and that is by RHS congruence rule. RHS congruence rule. So, therefore, by CPCT, that is corresponding part of congruent triangles. Here we can see that triangle POA and triangle COA are congruent. So therefore, what we can say that angle POA is equal to angle COA. Therefore, by CPCT, angle POA is equal to angle COA, or we can say that therefore angle 1 equal to angle 2, and let this be question number 1. Now, let us in the same way we can also prove that angle 3 is equal to angle 4. There is no need to prove it, just simply will write similarly. Let's go in the next page, that will be better. Similarly, angle 3 equal to angle 4, and let this be equation number 2. Therefore, now let us go back in our figure. What we can see that angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degree. So that is what we'll write. Also angle 1 plus angle 2 plus angle 4 plus angle 3 equal to 180 degree. Why? Because you see the figure, you'll be knowing the reason for that, because PQ is a straight line. Because PQ is diameter of the circle. PQ is diameter of the circle. Therefore, straight line. Therefore, because PQ is a straight line of the circle, therefore what we can say that therefore it is a straight line. Therefore it is a straight line, and therefore we can say that angle POQ is equal to 180 degree, and so this is the reason for that why we have written angle 1 plus angle 2 plus angle 4 plus angle 3 as 180 degree. Now let us move back to our figure. In that, what we have got is angle 1 is equal to angle 2 and angle 3 equal to angle 4. So what we need to prove that angle 2 plus angle 4 is 90 degree. So now what we'll do, we'll replace angle 1 with angle 2. So we will write here therefore angle 2 plus angle 2 plus angle 4 plus angle 4 equal to 180 degree. Why? Because from 1 and 2, what is 2? 2 says angle 3 is equal to angle 4. So we can replace angle angle 3 we can replace with angle 4. Also we can replace angle 1 with angle 2. From where? From equation number 1 already that we have proved. Angle 1 is equal to angle 2. So adding them we are getting 2 angle 2. Therefore 2 angle 2 plus 2 angle 4 equal to 180 degree, and therefore we can say that take out 2 common, angle 2 plus angle 4 equal to 180 degree, and solving it we will be getting therefore angle 2 plus angle 4 equal to 90 degree, and therefore now let us move back to the figure. Angle 2 plus angle 4 is nothing but the angle AOB. So therefore we can say that angle AOB is 90 degree. Therefore angle AOB equal to 90 degree. So this is the solution of question number 9, exercise 10.2. Question number 10, exercise 10.2. Prove that the angle between the two tangents drawn from the external point, that means this angle P, to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center, that means angle O. So we have to prove here that angle O plus angle P is 180 degree. So it is very simple. Why it's simple? Because angle A is 90 degree by theorem 10.1. Also angle B is 90 degree. That also by theorem 10.1. Together they will be 180 degree. Also, if when we are seeing APBO, what it forms is a quadrilateral, and we know that the sum of all the 4 angles of a quadrilateral is 360 degree. Out of that 2 angles sum is 180 degrees. Therefore, obviously angle P plus angle O will be also 180 degree, and therefore they will be supplementary. So let's start doing this one. Solution 10th one. Here OA is perpendicular to AP. OB is perpendicular to AP. Why? Because tangent is perpendicular to radius at point of contact. At point of contact. Therefore, what we can say that angle A plus angle B is equal to 90 degree plus 90 degree, and that is equal to 180 degree. So let this be equation number 1. And now let us go in quadrilateral APBO. In quadrilateral APBO, angle A plus angle P plus angle B plus angle O equal to 360 degree. Why? Angle sum property of a quadrilateral. Angle sum property of a quadrilateral. Now, so let this be suppose equation number 2. Therefore, using 1 into or putting 1 into using 1 into we have, let us see what we have. We have, so in place of angle A and angle B, we will put 180 degree. 180 degree plus remaining will be angle P plus angle O, that is equal to 360 degree. Therefore, we can say that angle P plus angle O equal to 360 degree minus 180 degree, and therefore angle P plus angle O equal to 180 degree. That means angle P and angle O are supplementary. So this is what we need to prove. So with this, question number 10, exercise 10.2 is complete. Question number 11, exercise 10.2. So this is our question number 11. Prove that the parallelogram circumscribing a circle is a rhombus. So let us first draw the figure for this. So solving question number 11. So what we'll do is we'll draw first. Let us draw the figure. So suppose this is the figure, and let this be A, this is B, this is C, and this is D, and let us so this is our figure, and AB, BC, CD, and DA, and they are here. AB is touching, let it be here point P, and this is point Q, this is point R, and let this be point S. Now we'll take the help of question number 8. What is question number 8? It says that the sum of the opposite sides is equal when the quadrilateral is circumscribing a circle. So here, though ABCD is a parallelogram, but it is also a quadrilateral. So we'll take the help of question number 8 here. Quadrilateral ABCD is a parallelogram. Also, it circumscribes the circle. Also, it circumscribes the circle. Therefore, what we can say that here, first of all, we'll get therefore AB plus opposite sum, length is AB plus DC equal to, that will be equal to the sum of the sides of the other pair, sum of the opposite sides of the other pair. So that is equal to AD plus BC, and this you will not write directly, but prove the same way as question number 8. Prove the same way prove the same way as question number 8. So I am not redoing it, but you will do. Next, what we are having is quadrilateral ABCD is in fact a parallelogram. And here if you see that AB and DC are opposite sides, and we know that opposite sides of parallelogram are equal. So let this be first suppose 1. Since quadrilateral ABCD is a parallelogram, therefore we can say that AB is equal to DC. Here you can see the figure. AB and DC are equal, but we know that in parallelogram opposite sides are equal. So AB will be equal to DC and AD is equal to BC and AD equal to BC. So let this be equation number 2. Now putting 2 in 1, we have, now what we'll do, in place of DC we'll put AB. So what we are going to get is AB plus AB equal to, and here in place of AD we can put BC, so BC plus BC. So we are getting 2AB equal to 2BC. So 2 is both sides, you can cancel them. What we are getting is therefore AB equal to BC. Therefore AB equal to BC. Now let us refer back to our figure. So here we can see that AB and BC are adjacent sides. So in a parallelogram, if adjacent sides are equal, then that parallelogram is a rhombus. So therefore we will say that parallelogram ABCD is a rhombus. So why it is rhombus? Because adjacent sides are equal. Adjacent sides are equal in the parallelogram. Adjacent sides are equal in parallelogram. So whenever adjacent sides are equal in a parallelogram, it is a rhombus. Adjacent sides are equal in parallelogram. So this is the answer of question number 11. So with this question number 11 is complete.